Well, we are recording again. So, as I said, welcome all. Thank you for attending again to a new session of our workshop. We are very happy today with the amount of people around and also with the wonderful speaker that we have, you will see. And just brief introduction, again, remind you that we have all the sessions online. They are available for you to revisit it. If you missed something, you want to check something that you didn't understand, you can watch the whole sessions and also you can access in the sessions, the codes that normally they are posted GitHub or this kind of platforms. You will find also the slides presented by the speakers in a Google Drive. Here are the links for the sessions that we have had so far. And again, I want to take just a few minutes to remind that we are hiring. We have a current open position. We are seeking, we are looking for a postdoctoral researcher in exposome research with experience in multi-omics integration to work with helix data and a bunch of exposome exposure variables. So if you work with us, please feel free to apply to this position. And as we've been doing in the other sessions, just a brief on past talks. As you remember, in the last session, we had the pleasure of having with us Ines Amin and Congron One that present, they gave a wonderful dimensional reduction technique and how these techniques for integrating multiple omic layers, heterogeneous omic layers, and also how these techniques can be used as well to study the mediating role of omics between the exposure and development of a certain disease. Specifically, they presented two case studies with helix data, with analyzing the helix population, focusing in BMI was the study presented by Congron, and another one in a more general health approach using a multimorbidity score by Ines. And they presented very well how to use two particular methods, the MOFA in an unsupervised way, and the RGCCA in a supervised way with like a multi-block PLS. In both cases, as you remember, we can extract latent factors from multiple omic layers that will represent different signatures across omics and so the relationship between the different markers and the correlation. And we can later use these latent factors to study the potential effect of environmental factors and also the link with the health outcomes. They did a really good job in summarizing the advantages of these methods. We have here a table with those advantages. And in general, we had a discussion, an enriching discussion on also on the potential limitations, no? Highlighting how with these methods it's sometimes difficult to deal with confounding effects and also how to address the noise that we have across the different omic layers. They are heterogeneous, and some of them we find more variability, and sometimes this is driving the whole result, or if one of the layers is higher dimensionality than the others, this can also result in problems. So this was the past session, and today we will move from dimensionality reduction approaches to the next step or area of this workshop, which is for looking more on mediation, but with specific methods for this and with a specific framework within this topic. We will have two sessions. Today's session, we will have a presentation by Dr. Vishal Midya. And in the next session next week, we will have a presentation by Dr. Jesse Goodrich. So now I'm gonna stop sharing. Maybe you can start sharing your screen, Vishal. And in the meantime, for those that you don't know him, Vishal is a postdoctoral researcher in the Mount Sinai, in the Icahn School of Medicine, the Mount Sinai. He will, like his background is biostatistician. He has worked as an environmental epidemiologist in Mount Sinai, and now he's particularly assistant professor in the Department of Environmental Medicine and Climate Science. And his research is focused mainly on understanding how prenatal and early life exposure to environmental chemicals eventually leads to adverse neurodevelopment outcomes later in life, and also whether childhood or adolescence gut microbiome can alter such detrimental effects. And today he's gonna present his work on strategies for multivariate mediation frameworks in environmental epidemiology. So whenever you want, Vishal, the floor is yours. Now we are seeing your slides, but it's not in full screen. It's in presentation mode. I don't know if...
Let me try. Okay. What about now?
It's okay. It's okay.
Right.
Yeah.
Perfect. Thank you so much. Thank you so much for the invitation. I am today going to share some of the strategies for multivariate mediation analysis, particularly focused on environmental epidemiology and exposure mixture methods. Sorry, can you unmute yourself, please?
Yeah, I would.
In this mediation framework, we will.
Please, all the people in the session, try to keep your microphone mute.
No, porque es un transición en el...
Sorry, Vishal, I'm trying to identify who's...
No worries.
Well, go ahead, and if in case it happens again, I will kick it off.
Perfect. Thank you. So we'll today talk about multivariate mediation frameworks, particularly based on environmental epidemiology. I'll focus today on exposure mixture-based methods. I'm an assistant professor at Mount Sinai in New York. We work a lot with exposure mixture type models. So many of my slides and this talk will focus on mediation through exposure mixture methods mostly. And next week, in a couple of weeks, Jesse will present, Dr. Goodrich will present mediation framework as well, but that will be not from the exposure mixture framework. So both together will inform current methods and state-of-the-art tools that can be used for environmental epidemiology mediation frameworks. Right. All right, the motivation. There is a critical knowledge gap in addressing the multivariate mediation setting in the environmental health literature. This is mostly because we don't work with one single chemical. We work with multiple different sets of chemicals. We work with multiple different sets of chemicals. And therefore, when you work with multiple exposures, the high dimensionality issues come in, right? So high dimensional mediators, and we have multiple exposures at the same time. So multiple exposures and multiple mediators. The problem here is there have been many techniques developed in different fields which can compress this idea or compress this dimension into individual indices. But then we are in environmental epidemiology and the indices need to make sense or be interpretable, right? And that's where the challenges come in. We want to work the methods that currently we're using with exposure mixture methods. We combine these exposures or combine these mediators in such a way that the interpretability remains the same. So the aim of the talk will be to possibly lay out all the possible different scenarios where the mediation framework is used in environmental health and what it means and what it doesn't mean. So we'll go over all of these topics one by one. Usually in the mediation framework, people have been working with the idea of causal mediation. So I have just written down some of the hypotheses for causal mediations. Although I should say that for doing particularly causal mediation analysis, there has to be some other conditions that needs to be met. So we cannot really make causal statements for many of our mediation analyses as such, just because there is some temporality. But still, this hypothesis should be kept in mind always. There is no unmeasured confounding between the exposure and outcome relationship. After controlling for the exposure variable, there is no unmeasured confounding for the mediator and outcome relationship. Similarly, no unmeasured confounding for the exposure and all the mediators, and there is no downstream effect between the exposure that confounds any mediator and outcome relationship. And temporality needs to be satisfied. The exposure precedes the mediator, and the mediator precedes the outcome. Now, there have been studies where everything, all the exposures, mediator, and the outcome are cross-sectional. That is, there is no temporality. So we have to keep this in mind, that when we are making inferences, we probably won't be able to make causal statements in those situations, definitely. But well, so all these methods that we'll be talking about, they are still applicable, but then the inferences should be based on associations, not causal effects. The data set. The examples that I'll be giving you or presenting today are based on the study population called life codes. It's a pregnancy cohort based in Boston. The study sample includes 160-ish women with complete exposures and multiple endogenous biomarkers. The biological samples, the urine and the blood, they were taken when around 23 to almost 30 weeks of gestation. The exposures, which is the main focus here, are different environmental chemicals like phthalates, phenols, paraben, PAH, and the trace metals. So in total, we have 38 analytes. Now, if you think about the exposure, large exposure mixture models, 38 is not a lot in that sense, but as an example, we can start with 38, and you can see like eventually you can build on top of that, right? And then we have the mediators. The mediators are our endogenous metabolites. We have 51 metabolites. Some use lipid metabolites, cytokines, and some protein oxidative markers. These are the mediators, 38 exposures, 51 mediators, and our outcome. The outcome, just for example, in two ways you can take the outcomes. One, I chose a binary outcome, and there is another continuous outcome, right? Because thus methods will slightly change based on what kind of outcome we are choosing. So 52 cases of preterm birth, defined as delivery less than 37 weeks of gestation, and 100 controls. And then the gestational age at delivery, which is a continuous. So this is our setting. We have 38 environmental chemicals exposures, 51 mediators, and 2 different types of outcomes. And we want to do a mediation analysis, right? So I'm upfront putting up the current literature, basically based on which, putting up the literature based on which many of the slides have been constructed. We'll be mostly and directly talking through our material basically comes a lot from this paper. It's called it's a Nature Communication paper by Dr. Ang. That is basically one of the founding paper, I would say, which talks about many multiple different mediation framework. But then along with that, I'll also include some of the exposure mixture-based methods in this mediation framework. And I have also listed some of the other methods that we'll be talking about, and these are the references. So please go over them. And I will come back to this literature and I'll refer them. All right, so what is the analytical framework here that we want to talk about, right? So there are conceptually, you can always do a mediation individually, right? So like a pairwise mediation, you can look at one individual exposure, one mediator, and one outcome. And you can do it like for all of them. So I had 38 exposures, 50 mediators, and then one outcome, right? So as you can think about, you can have all 38 multiplied by 51 combinations. That is possible. But then that is the most interpretable as well. But then we have to pay some cost because that is the way too flexible. The other way can be done using something called the exposure class specific risk score. There we create exposure mixture indices. Now, there are many different ways to create these mixture indices. So we have to keep in mind that what all of these indices really mean and what am I doing here, right? And then we can create an index on the exposure side, and you can have single mediator at each of the time points, right? So in that case, you have one exposure index multiplied by 51. So we do basically 51 different analyses. Another way is you can create an exposure class specific risk score, and you can also combine the mediators, right? So which would be the possible best way to do, in the sense it combines the information. But again, we have to make sure what the mediation that we are doing is the results they imply, or if the exposure mixtures or the exposure risk score or the pathway specific multiple mediator combination, if they really make sense interpretable wise, right? All right, so now I'll go over each of them one by one slowly. The first one is the first approach. This is the simple pairwise mediation with individual exposures and individual mediators. What we do, and this is a figure from this paper, which kind of summarizes what you want to do here, right? So again, we have exposure analytes. We have 38 exposure analytes, and we have endogenous biomarkers 61. And our outcome, it could be gestational age at delivery, or it could be the binary outcome, right? The binary outcome was preterm birth, right? And people usually, this is the easiest thing to do and also very interpretable, will do this mediation for each combination. But as you can think, right, the moment the number of exposures and number of endogenous biomarker increase, the computational cost increase a lot. And if you don't really have a huge sample size, then you have to pay for the multiple comparison error, right? So that is not the best thing to do, but still it has its own charm. Just to add some equations, just to make sure that we understand what we are doing here in this pairwise mediation analysis with individual exposure and individual mediators. This A here is basically the exposure, the single exposure, let's say one single phenol, and our M is the mediator, right? It could be one of the proteins, could be something else. So A is the exposure, and C are the covariates, and M is the mediator. So as I was talking about, we have 38 exposures and 61 mediators. So almost 2,000 unique mediation models. This approach is useful when there are few exposure variables and we know we have very targeted mediation, like 1 or 2 mediators, right? That makes sense. But then if we do all those 2,000 unique mediation models, the issue of high bias in type 1 error comes in, because of the multicollinearity, right? And we have to also keep in mind many of these exposures and many of the mediators, they're very much intercorrelated also. So high bias probably due to type 1 error. But then if we also overpenalize, there's a good chance that overpenalization due to multiple comparison error, high type 2 bias also. So we have to be careful of how we do the p-value adjustment procedures. Usually, many of these studies, we don't have a huge sample size. When I say huge sample size, I imply more than 1,000. Is there any mediation method applied in longitudinal data framework? There are. I'll go over that at the very end. But let me first finish these one single time points first, and then we can kind of conceptualize how these methods can be used for longitudinal data framework. All right. So again, so we have to be careful of how we are dealing with the p-value adjustment procedures here, right? cannot be too strict, also cannot be too lenient at the same time. But the good thing that as practitioners in environmental health, we like that this is the most interpretable framework, and we really know who is the mediator, and we can really look at each of the individual exposures and the mediators, right? And there are multiple packages, R packages, or you can even use Python packages in SAS also. There are multiple packages there. And well, this is, if you are not familiar with these packages, you can use this package called mediation R package. It's very interpretable and very easy to use. So I have a link also to that. So here again, this is the pairwise mediations. I like it a lot, mostly because this is very interpretable. So we can kind of conceptualize what really happened. But then at the same time, we are not taking into account the fact that many of these exposures, they share information, implying they are correlated. So do we really need to do so many analyses? Maybe not, right? All right, this is another figure from the same paper. A very nice and succinct way to present your analysis. You can think this as a Manhattan plot, right? So what we have here on the rows, we have the phthalates, phenols, and parabens, pH, and the trace metals, and you can see their different colorings. These are the association estimates. This is all the 2000 associations that you actually have with different colors, and these are the mediator groups. And this dotted line is basically the cutoff for the p-value after multiple comparison. So here you can see there are some which actually like goes above the thresholds, and you can obviously you can change this cutoff depending on your requirement, right? Again, interpretable, but we are obviously missing out some information also. The information where the mediators may be grouped together or the exposures might be grouped together, right? So very nice way to present this in terms of the Manhattan plot, and these are the p-values. All right, the next one, the next approach where we talk about is the exposure class-specific risk scores and one mediator at a time. So when I say exposure class-specific risk score, what do I really mean? I mean that I somehow want to combine these exposures together. I want to combine, for example, if I already know that some of these chemicals are phthalates, why don't I combine the phthalates? Same for phenols and parabens, pH, and metals. Maybe even I can combine all of them together and create a overall exposures specific risk score, right? So what are the possible ways of to do it? Now, in this paper, note that they don't really talk about this exact exposure specific risk scores, the way I'll be talking about, but then the concept is there. In these slides from now on, I'll be using some of the methods or the exposure mixture methods, and I'll talk about how they can be used within this mediation framework, right? So the mediation analysis with exposure class specific risk scores and one mediator at a time. What is the aim here? The aim here is to create the exposure class specific risk score and use all the exposures simultaneously. Now, why do we want to use all the exposures simultaneously? Because there is a sharing of information, right? And we want to capture the sharing of information at the same time. And then basically, we don't have to do too many of the analysis that saves our computational effort, one, but then also we don't have to penalize for multiple comparison error, which is a very tricky thing. And you have to adjust the p-values for the multiple comparison error when you are doing this set of mediation framework. Well, that's fine. But then the problem comes in because the correlation between the exposure needs to be addressed. Many of these analyses that we have been talking about, the mediation framework is based on linear models, right? And what is really important here is the beta estimates. Now, if the exposure are very much correlated, that means they somehow bias the standard error. And if the standard errors are biased, that also implies the effect sizes eventually, the p-values of the p-values, so not the effect, sorry, the p-values, they get biased, implying the p-value gets biased. So we have to be careful of like how to treat this multicollinearity issue without biasing our eventual p-values, right? A possible solution to this is something called, we create this environmental risk score. Now, there are many ways to create these risk scores. I'll be talking about a few of them, but in literature, you actually will see that there are multiple different ways to create such a risk score. There are two major types. One of the types is based on elastic net time models, right? Lasso or reach time models. And the other type is the exposure mixture based models. Even within each of these groups, there are multiple methods. So the first one, we'll go through the elastic net time models and what it does, right? Elastic net time models. So elastic net and all of those related algorithms, they're really good for predictions, right? Which is very nice in terms of predictions, but how can we use those elastic net time models in our framework? Because we have to remember that at the end of the day, we really want to know the direct effect, indirect effects, or the proportion explained, right? And basically the beta estimate is the main key here. And we want to know exactly about the beta estimates, not just the R square or not how good it is predicting. So we have to be careful when you are using a model that is made for predictions in a mediation framework. So again, the goal is to reduce the effect of correlated exposures. That is what we started with. So we have multiple, like 38 exposures, right? And we know some of them are phthalates, some of them are phenols and parabens, some of them are pH, and some of them are metals. So intuitively, and it makes sense that we start with 4 different exposure groups. Maybe we can like combine them later on, but let's start with the 4 different groups. So we start with 4 different exposure groups: phthalates, phenols, pH, and metals. And the good thing about using elastic net time models is that even if the exposures are correlated, we can actually put them all together in the same model and we can penalize it. Therefore, what happens is if your effect estimate for one of the betas are very small, it's going to push it to 0 and going to keep it the larger effect estimates as it is, right? So that there is, even if there is correlation, these models can take into account the correlations. However, there is an issue if we just use lasso here. Probably should not use directly lasso, because lasso usually ends up choosing almost randomly any of the correlated exposures. So the suggestion would be to use elastic net time model, something between lasso or ridge regulations. All right, so why elastic net time models? Because they can actually take into account the correlations, right? Correlation between the exposures, we don't have to worry about that so much here. Just like say in linear regressions, right? If we use the correlated exposure in a linear regression, there's a very high likelihood that there'll be multicollinearity issues. In here though, we are not going to worry about that. So we create elastic net time models, that is all fine. But then we have to also remember there is a penalty term. And depending on how much you penalize and how you choose a penalty term, your effects of the betas are going to be different. So that has to be kept in mind when you are creating such risk score for mediation analysis. So my suggestion would be to be upfront about the penalty term and how much you're penalizing and how you're creating these methods, creating these indices upfront. Because depending on the penalty terms, the exposure risk score will be different, slightly even, right? So it is very important to be upfront about this and how you created them. Anyways, so we have the elastic net time models. There is also another way, not exactly similar, but almost similar, which is based on the support vector machine type models. So support vector machine again are used for predictions. You use basically create a hyperplane and try to discriminate between 2 different classes. But there have been a bunch of papers recently, and I have put some the reference also, which combines the support vector machine as well as, you can see, I just put this equation just to show that you can combine these support vector machine type models as along with different types of penalty from elastic net type models, and you can create a ERS score also. So there are multiple ways within this particular framework of elastic net type models. Either you use a lasso or ridge or something in between, or you create something with support vector machine. You will obviously end up creating exposure risk type models where the correlation between the exposures are taken care of, but something that in the paper, it should be clearly mentioned what method was used and what was the penalty. Again, if you're using some penalty, that basically means some of the betas are going to be different depending on the penalties. So, and because we eventually want the direct and indirect effects, the beta estimate. So it is very, very important to be upfront about the methods and how it was created. So again, overall, we do have very interesting, and these methods are very fast. That is one of the very, how do I say it, user-friendly thing about these methods. They're very fast, interpretable, but again, when you are trying to interpret the associations or interpret how the risk score was created, just make sure that you understand like how you chose your penalty term and how you chose your models. A trick part here is that many of the effect estimates that you will get, see this gamma k, they may be both positive and they can be also negative. Now, some of them will be like very zero, very small because of the elastic net type, but some of them will still be like positive and negative. So when you combine them, there might be a slight possibility that in some cases, the overall ERS score might go to null. There might be possibilities there. Not always, but there are still possibilities. So be careful, right? Things to consider, the coefficients of the ERS score can be both positive and negative. And the coefficients, they don't sum up to a constant always, right? And in most cases, they do not sum up to a constant. So individual ERS values can vary depending on the model hyperparameters chosen and depending on the elastic net, like what kind of elastic net model you chose. So it should be definitely mentioned in the paper so that anyone else can replicate that. And it is a perfect candidate for prediction, but its use in constructing the ERS score needs more consideration. The next one is the exposure mixture type models, right? What is the exposure mixture? What is the exposure mixture type model? In exposure mixture type model, the idea is that let's say we have multiple different exposures, they are correlated. What we do is we create a weighted index, and the weights, because they are weights, they are always from 0 to 1, or they are proportions. So we create a weighted index, combine them. Once we create a weighted index, then we look at the overall association with the weighted index. Now, there are many ways to create the weights, but again, unlike the ERS score, we are not using individual betas here. More like we're using individual weights. We combine them, basically, create a weighted index, and then we look at the associations with the outcome. And there are multiple methods. One of the very first methods that became very popular and still very useful is called the weighted quantile subregression. And the weighted quantile subregression has multiple different variations. There are Bayesian variations also. There is something called Bayesian kernel machine regressions. They are all, in some sense, exposure mixture models. They somehow create the weights or contributions for each of the exposures and how you combine them, right? So the other way, instead of working with the ERS scores, we can use the WQS or Bayesian WQS type models, right? So we can extract the weights and create the class-specific ERS scores. Now, an individual ERS scores are bounded and they should not vary drastically, right? Because, well, we have the weights. So the weights are between 0 and 1 always. So when you sum them up together with the exposures, you are not probably likely to end up having the null effect factor, right? They are not positive or negative. The weights are all positive. So you combine them. using the stratified, and there are many different ways to create the ERS scores, the ERS scores using exposure mixture models. I'm not going in deep about how there are many flavors of WQS, many flavors of Bayesian WQS or BKMR. I'm not going into those things, but that is something that should be thought about when creating a exposure class specific risk score. You can obviously work with both the elastic net type models and the exposure mixture type models, but again, the interpretation is slightly different. The exposure mixture type models, it's a weighted index. It basically weighs, gives you weights or how much your contribution, it somehow measures that. Elastic net type models is where your beta can be both positive and negative there, and they are based on some sort of penalization. In the exposure mixture type model, for example, the WQS models, there is an inherent way of taking into account the correlations between the exposures. How they do it? They actually use, within their modeling, they use something that random forest does. Instead of choosing all possible exposures simultaneously, they chose like a subset at each of the iterations and creates somehow uncorrelated subset, just like random forest does. So in some way, in that sense, it can take into account the correlations within very much intercorrelated exposures. So again, coming back, we have two types of models here, the elastic type models or the exposure mixture type models. Exposure mixture type models are much more interpretable because you have the weights. So you create an exposure risk score and you look at the weights and you really know like which of the chemicals have the higher contribution versus the others. So the interpretability matters in environmental health. And so my default choice would be an exposure mixture type models. Now you can choose the exposure mixture models depending on your questions or the context, but it's a very nice and easy way to create an index, right? A good thing also is that you can create an exposure mixture type model, not just for the phenols or the parabens, but you can also create for the whole group. There are methods like group WQS or the group BWQS. In BKMR, there is something called the hierarchical BKMR. So there are multiple ways and they all have their pros and the cons, but at the same time, these are much more interpretable to combine exposures. However, this is something that needs to be noted. When you create an exposure mixture, this is supervised. This is not unsupervised. Therefore, the index that you are creating X, the ERS, it has a component of Y in it. So when you use your mediation framework, is there a Bayesian model average in the mixture? Yes, there can be. There are works on Bayesian model averaging in mixture models. I'll come back to this later on once I'm done with the slides. Again, so the ERS score that you are creating, it has, how do I say it, a supervised component in it. So therefore, when you are creating the, looking at the direct or indirect effect, be careful how you interpret them. This is not unsupervised like PCA. So there is a slight difference there, right? So keep that in mind. These are the packages there, all these packages, and there are vignettes also. And you can go over the vignettes and you can implement them. They're easy to implement, but again, when you do your inference, be careful of what estimate it means, right? All right, so now that we created so mediation with the exposure class specific risk scores and one mediator at a time. So let's say we had 4 different groups. So now we can choose to have only so these 4 different ERS scores, or you can actually combine them together, get one single ERS score. And then you have individual mediators. We can utilize the mediation signals and we can use usual mediation framework there, right? Note that the ERS score should be standardized or you can quantile them, right? Otherwise, probably the ERS score, the estimates may not be comparable from one group to the other group. So it is always important to standardize or make them quantiled. You can have 4 ERS scores, 64, 61 mediators, around 200 to 50 mediation models. Not as much as 2000 is almost like 1/10, but still you have to like think about the multiple comparison error due to p-values. And again, at the same time, ERA score, if you create with any of these methods, and there are papers, a lot of papers which use the elastic net time models or the exposure mixture time models, your ERA score is informed by the Y already. So be sure how you interpret that correctly. The last approach, where we combine all of these exposure mixtures and also combine the mediators, right? Now, the trick part is, how do we combine the mediators? There are, as you can think about, there are multiple ways to combine the mediators also. The mediators may be informed by Y, which is like a supervised combination, or they may not be, they may not use any information on the Y and may be created completely unsupervised, like PCA type models, right? So there are pros and cons for both of them. I'll go over some of the methods that people have used in their papers. But again, the interpretations are the key. So there are many methods almost simultaneously, almost equal, but the interpretations may vary drastically. So keep that in mind. All right, what is the overall goal, right? Like if I create multiple exposure indices or multiple mediator indices, like how do I present my results? Like what's the overarching goal here? Well, at the end of the day, in my paper, I would like to create a figure like this, right? On your rows, you have the biomarkers, the different pathways, and then on the columns, you have the risk scores. And this is a very nice visual that Dr. Ong came up in his paper in the Nature Communication. You can see just by looking at this figure, it's like a matrix almost. By looking at this figure, you actually get an overall idea like what exactly is happening. So for example, the first row is all the biomarkers, and you have their total effect, indirect effect, and direct effect. And then for each of them, right? And you can also combine, so the first one, for example, the first row and the first column, you can see like overall picture, and then you can go to the nitty-gritties, right? In this whole matrix. So this is what I want to do. But again, depending on how we create these exposure mixtures or we combine the mediators, the interpretations are going to be vastly different. So keep that in mind. There are major 5 ways, but there are obviously, I'm saying 5 ways, but then methods like this are always being studied in the statistical literature. So there are multiple different ways, but these are the 5 major ways that the environmental literature has used for creating multiple mediators within the mediation framework. The first one is the PCA-based approach, where the thing about PCA-based approach or the sparse principal component-based approach is that it is completely unsupervised. That means that if we create a PCA-based mediator matrix or mediator risk score, for example, it has nothing to do with the Y. It's not informed by Y. In all the other methods that you will see, both the Y and the M and the exposures, they all somehow share information. So be careful of how you interpret them again. Principal component analysis. We have all probably done some sort of principal component analysis as part of our research. PCA is very efficient and very fast. However, the trick part about creating a PCA index is that the interpretability is not always upfront. Depending on the situations, it might be interpretable, but may not be very interpretable. And if it is not very interpretable, it is obviously, we are working with environmental health, we on interpretability, right? There's something in the chat. I'll come back to this. This is a long question. Give me a moment. So
we can do questions from the end for the end if you want, Vishal.
Yeah, I'll go back to the questions one by one at the very end. So the principal component analysis. So we can create PCAs depending on the mediators. That is all fine. However, the good thing about the PCAs are they're orthogonal to each other, so they can explain the variances separately, which is also nice. However, the interpretability is the problem. There are ways. There is a huge literature on something called sparse principal component analysis, and there are many different versions of sparse principal component analysis. What it basically does is creates a more the loadings or the weights are somehow sparsed. So then if you look at the weights, it's more interpretable in that sense. It's almost like the exposure mixture type models. So you can look at the weights and you can be like, oh, well, I do understand this has higher weight versus this has low weight, almost no weight. So more interpretable there. However, note that both the analysis take into account the variations in the mediator and they do not incorporate the outcome. So it is in that sense unsupervised almost, right? So very easy to use, both of them, but more likely for interpretability, it is recommended to use the sparse principal component analysis and choose probably the first two principal components, right? So that's one way. What about the other ways? Similar to this, they're not exactly principal component type analysis, but they are called principal component regressions, or PLS, the partial least square. In spirit, they are similar to PCA, but the mathematics, they systematically differ from the PCA. Why? Because it incorporates both the mediators and also the outcome in the reduction process, right? So therefore, they're supervised. And they both can be used, they both can be used as the machine learning algorithms for predictions. So you can decide on the number of components in many different ways, like almost like choosing the right hyperparameters, leave one out methods, or multiple different cross-related methods. But again, remember, slight differences from the PCA type with this PCR is that you incorporate the outcome here. So you're creating a mediator informed by the outcome, which is not a bad thing, but still keep that in mind. So if you have in your system, you have the exposures or the risk score informed by the outcome, and also you have the mediators informed by the outcome, you have to make sure when you're doing the mediation analysis, that is the direct and indirect effect are interpreted in a correct way. Then we also have the mediator mixture-based approaches, right? Which we talked about last time is you can create the exposure indices on the risk scores for the exposures with the mixture methods. You can also do the same thing with the mediators, right? Almost the same idea, the same create the mixture-based mediators and the mixture-based exposures. But again, unlike the PCA here, they're also informed by the Y. So the most important thing then becomes is, well, I created an exposure index, I created a mediator index. What about the relation between them? That is then becomes the most important thing to understand. Again, the intuition here is to create the mixture indices correspond to the literature-derived mediator group. Now, if you're using mediators and you already have some idea beforehand that, well, I have some of the mediators which belong to some certain pathways, you can obviously combine them, right? And you can create the mixture index based on the mediators. And if we do so, the whole analysis can be boiled down to very few regressions, right? Which we all want. However, note that both the analysis take into account the variations in the mediator, that is M, and also incorporates the variations in the Y. So need to be careful. And then the next couple of slides, there are two different methods. One is a population value-based decomposition for the mediators, and the other one is the Bayesian continuous mediation regression, shrinkage. In both the methods, you actually incorporate, so for the population value decomposition one, it's a dimension regression technique that uses some flavors from the structural equation modeling, right? So you can, as you can see, like these are all set of equations, and the ideas from the structural equation models can be borrowed into this mediation framework. However, when you create that, the most important part is to understand that there is a mutual share of informations between the outcome, mediator, and the exposures when you are creating these indices. So keep those in mind, right? In this particular population value decomposition for the mediators framework, the main goal is to reduce the dimensionality of the mediator matrix, determine the extent of which individual chemical exposures are mediated by the whole group of endogenous biomarkers, either as a total mediator matrix or biologically relevant groups. So you can take them as a whole instead of creating like combined indices, or you can actually make them as a group. So you treat the whole matrix as a whole. You don't create an index anymore here, but this is part of the structural equation models. So that gives you a flexibility to having like different segments. So you treat the whole mediator matrix together. So therefore, the new mediators, lower dimension representations are functions of both the exposures and the outcome. So now you're creating some mediators, or the, how do I say, lower dimension representations informed by both the exposures and the outcome models. So be cognizant of what the effect sizes or the direct and indirect effect mean in those situations, right? And they're not similar, but there is different shrinkage methods in the Bayesian ways also. And one of the very famous one is the used in the called BAMA package, which is a Bayesian shrinkage method, where you see you work with the matrix of mediators. You don't work with individual scores, but you work with a whole different set of matrices simultaneously. They are obviously different in their philosophies, but at the end of the day, you want to eventually, instead of creating scores, you want to work with the global mediation effect of multiple mediators of the whole matrix together simultaneously. So both these methods, the population value decomposition method or the Bayesian continuous mediation shrinkage, they allow you to work with the whole matrix as a whole instead of creating indices. But then you are informing each other with the information from the outcome, also information from the exposures. All right. So then, I mean, once you obviously end up creating your favorite indices on the exposure sites and all the mediator sites, you use the mediation package, which is, and there are many different sets of mediation packages. There is one through Lavan, there is one through mediation R package, and you create your mediation outcome. So this is the mediator group. For example, this is the ERS, and then you have the outcome and the mediator and the phenols, and they do mediate, right? One thing to keep in mind that I have noted that when you are repeating this whole process, you have to repeat this whole process multiple times. Otherwise, your p-value is susceptible and it can change drastically. So one suggestion that I have noted, at least in my examples, is that you have to repeat this whole process a good number of times so that your p-value eventually gets stable for the direct, indirect, and the total effects. And the package also lets you incorporate exposure mediated interaction models. I haven't gone through the interaction model as such, but if you use the exposure mixture models, there is a way that you can incorporate interactions there as well. And some of these packages can lets you to incorporate interactions in the mediation. But again, there should be a good a priori hypothesis of why you are doing so. And many of the scripts are here in the GitHub pages, and the codes are there and everything is really nicely explained. So please feel free to go there and explore. And thank you.
Thank you so much, Vishal. Wow, this was a huge piece of information. I think it's a really good job what you did, trying to summarize the different approaches and even the different methods within approaches, highlighting advantages of each of it for each situation. We have some questions in the chat. Maybe I can take them back to you. Well, we have a question from Arce. She asked about the mixture approach. I think she was referring that if you are in a situation where you expect that your exposures, all of them are harmful, or all of them they are beneficial, and you have different groups, they can cancel out, no? And she wondered if you could model these exposures through two separate mediation models in that case, instead of using a whole model for all of them.
Very good question. Yes, this is something that I did not go through, but this is a very, how do I say it, burning question in the exposure mixture model framework, right? How do you combine these exposures? So in the weighted quantile sum regression framework, you can actually create an index based on, if you hypothesize if there is an adverse or like adverse association. So you can create for positive index and you can create something for the negative index. And again, at the same, exactly, and then you can do like two separate mediation analyses. You can even put them together as long as the indices are not correlated by themselves. You can do that. But yes, in WQS type of analysis, you can actually create two different indices. And that is basically the background idea. Yeah.
Yeah. Okay, thank you very much. And another question from Ines, about reproducibility of results. Is it recommended to validate the results on an independent data set? A lot of
Absolutely.
presented methods are based on predictive methods, risk scores for exposures and mediators. Yeah.
Absolutely. I mean, the more the cohorts, different cohorts, the better, right? But yes, absolutely, it is extremely important to have a validation cohort. But we are not always lucky enough to have another validation cohort usually. But yeah, that will be the best idea. If you are using any of these machine learning sort of methods, then definitely yes.
Okay, thank you very much. And another question from Edmond Sakla. Is there any mediation method applied in a longitudinal setting?
There are many of them for one single or a sort of a number of mediators, sorry, number of exposures, but then putting all the exposures and all the mediators together in a longitudinal framework. I don't think there are many methods. Many of these algorithms that can be somehow repurposed for that aim. But again, we have to take into account the correlations between the created exposure score and the created mediator group. It can be done. I haven't seen much as such. But there are statistics literature which actually does high dimensional mediation on longitudinal framework. There are, so it has to be, what is it, incorporated in this environmental health literature now.
Okay, now people is starting to post more questions. Another from Willing. Great presentation, thank you. You talk about no confounding assumption for the mediation analysis. In an observational study without a randomized scheme, what do you suggest to do to satisfy such assumption?
It is usually, again, that's a very good question. That's a very, if we are interested into making causal estimates, we can always do covariate balancing before we start this, right? We can always do covariate balancing, use propensity scores or something like that, create two somehow similar propensity-wise distributions. You can obviously do that and start this whole process. So yeah, it can be done. But again, I mean, no confounding assumptions maybe are be more, how do I say, important than if you, the idea is to create causal estimates. So yeah, then covariate balancing or the propensity score-based methods are the way to go. And then you create this whole framework after that.
Okay, thank you very much. Also, there is a question from Jin Xiao Yang. I think you mentioned it, but maybe it's good to put more emphasis. Is it possible to trace back to specific exposures to contribute to a score?
Yes.
When you build a mixture?
Yeah, definitely. That is the, I think, the inherent, how do you say, the inherent quality of a mixture method. You can actually trace back and interpret, like if this particular chemical is contributing more to an index than with respect to some others. So yes, you can always trace back. And that's what we want in environmental health, right? We want to create interpretability, and the exposure mixture methods offer you that chances.
Okay, thank you very much. Also a question from Seiyu Lee, I think also was commented. How do we deal with collinearity multiple times?
collinearity within one single time point, these exposure mixture methods can actually handle. For example, the Bayesian type models, they put different sets of priors, right? In such a way that the exposure, the correlation can be handled. And in frequentist way, like the WQS type models, they already incorporate random forest-like structures. So you don't work with all the exposures simultaneously. You choose certain exposures for different bootstraps. So what it does is like it creates multiple different bootstraps and then aggregates them. So in that sense, in one sense, it's a model averaging, but at each of the bootstrap, you choose randomly some exposures. Now, because you're choosing the exposures randomly, and if you do it multiple times, there's a good chance there's the overall mixture effect will be somehow uncorrelated. So that's another way. So yes, many different ways. And then obviously there is the lasso type or the elastic net type models that we can also use. So there are ways, yes, that can be used. But again, you probably need to check the results with multiple different methods just to make sure that they are also similar.
Following on this, like this is a personal question, have you seen within approach 2 and this sub-approach of using mixtures models instead of just the lasso or the elastic net, have you seen, apart from WQS or BKMR, the glinternet using this mediation framework? You know, glinternet is
Yes,
very
I have.
elastic.
Yeah, I haven't tried that. No, I myself haven't tried that, but I haven't also probably haven't seen papers on that. But I have seen that probably that can be used. Yes, definitely. Just to have like comparable set of results. But I myself hasn't tried that. No. But
Okay,
thank you.
thank you very much.
Yeah.
And I think we are ahead of time now. Just a brief conceptual question from my side is, at the beginning, one of the first slide was about the assumptions, no? They are strong assumptions that we have to meet before performing this kind of analysis, that sometimes they are not met in many experiments. And you mentioned that the exposures needs to temporally precede the omics, no, the mediators.
Right.
Am I right?
Yes. Yes.
And I wonder if the mediators should be also temporally before to the outcome,
Ideally.
or ideally they should be, no?
Ideally, they should be yes. Exposure, then mediator, then the outcome.
Yeah. Because we find many of the study designs, we have actually the exposures measured like in pregnancy or in times before, but sometimes the omics, they in most of the studies they are measured at the same time of the outcome, and we have some special omic layers in which it can be a kind of bidirectional way between the outcome and the omics. And yeah, I think that's important also to take into account before trying to apply these methods in any study design.
Definitely. I mean, we cannot make causal statements then, right? This is not causal inference anymore then. I mean, we can use the methods like covariate balancing in other types, but probably not make causal inferences from there.
Well, so I think that's enough. Thank you very much, Vishal. Deep thanks for this wonderful talk, and thanks everyone for attending the session and being so active in the chat and putting so much attention. So thank you very much, everyone, and see you on next week, next Wednesday. Okay, thank you very much. Bye.
Thank you. Bye.
Thank you. Bye-bye.